In this video, I'm going to go do an overview about linear functions or linear equations. So these are the simplest functions, and this is what you usually start with in school. Linear functions are just straight lines, and they have a nice form. It's a simple form to work with, and simple properties. So, for example, you could have this as a linear line. You could have, so this is a positive line here. You could have this as a linear line. So they're just straight lines, and this is how they would look like. Straight linear lines, linear functions. And they have the form of y equals to mx plus c. This is the general form. You also have the form of ax plus by plus c equals to 0. You also have ax plus by, so I'm not going to call it c so that you don't confuse it with the c, so I'm going to call it plus d, or you could have it in this form. So 3 different forms. This is the main one, and you'd start with this before going to the others. So this is, this is the y-intercept form, not the general form. These 2 are the general forms. So this is the gradient intercept form. So I'm going to talk about gradient intercept form, then I'm going to get to the other forms. This is the gradient of the function, and you should have seen how to find the gradient. It's you taking the 2 coordinates, so you'll always have to take 2 coordinates. You're going to take the difference of the y values and the difference of the x values, but they have to be in the same order. So if you started with the second coordinate, then you have your x has to start with the second coordinate. And if you start with the first y, then your x has to start with the first y. So these 2 have to be in the same order, and remember that it's y in the numerator, x in the denominator. So this is the gradient. This is the y-intercept. And y-intercept is the value that crosses the y-axis. So if you have this as a graph and your graph does this, then this is where it crosses the x-axis. So if c was 5, then this value is 5. That's the probability it has. So for example, you could have y equals to 5x plus 3. Then I know that the gradient is 5 and the y-intercept is 3. There's also the condition that if your gradient is, so if m is positive, so greater than 0, then you'll have an increasing gradient. So you have something like this, an increasing function. And if your gradient is less than 0, then you have a negative gradient, then you have a decreasing function, so something like this. So these 2 would help you understand what your graph is if you're doing it correctly as well. Now there are a couple of things that you should essentially know. One of them is how to find these equations. And there are different ways, so I'm going to focus on the y equals mx plus c first. 2 ways is 2 possible routes to find the equation of the function is if they gave you the gradient and 1 coordinate. So let's say I gave you that the gradient is 2 and the coordinate is negative 1, 3. What this means is that I have a graph which has a gradient of 2, and if I draw this line for this graph, it's going to cross the point of negative 1, 3. So this is a coordinate on the line. So phrase is such that one thing you need to keep in mind, if it lies on the line, so if it lies on the line, if it says this coordinate lies on the line, if it lies on the line, so then it satisfies the equation. It satisfies the equation means that if I plug this into my equation, it's going to fit. It's going to nicely fit and everything's going to be equal. So that's the main thing you need to remember. So if they gave you the gradient and the coordinates and they want the equation of the line, so we want to end up with y equals to something, a value for m, so the gradient plus the c. So the thing, we have the gradient, the thing we're missing is the c value. So we have y equals to 2x plus c. We don't know what the c is. Now this is wrong, just to leave it to this way. You need to find c. And we don't have a way to find it because right now we have this, this, and this that are unknown. But if you notice, this coordinate lies on the line, which means it fits the equation. So it has to fit here. So instead of y, I'm going to write in 3. Please be careful. Don't pick -1 just because it's on the left. It's 3. You need the y coordinate. And then you have x. Again, be careful. Don't pick 3. You need to pick -1. So we've plugged this in here and it should work. So I'm going to have 2 times -1 is -2 plus c. And if I'm going to solve it for c, I'll just add 2 on both sides. So I end up with c 3 plus 2. That is 5. So you don't stop here because this is only one mark. So you're going to write y equals to 2x plus 5. So your c now is 5. You don't put in -1 and 3 again. This was just an example to help you find c. The equation of the line is just y equals to 2x plus 5. So this is how you do it using 2 coordinates. Let's say you had, let's say you didn't have the gradient. So this is the second case. If you didn't have the gradient, but you knew another coordinate, you knew that the other coordinate was 4, 9. Okay, so sorry, not 4, 9. Let's say 2, 9. 2 and 9. So now that you have 2 coordinates, how would you find the equation of the line? Well, you're missing the gradient now, and you're missing the c. Now you can't find c unless you've actually found the gradient, and you can't find the gradient unless you have 2 coordinates, which you have in this case. So we're going to use the 2 coordinates, and I'm going to show you how to calculate them. So remember the numerator has the y, so I'm gonna start with this. So let me make an arrow just to show that I'm starting here. So it's gonna be 9 minus 3. And the denominator will be 2, so I'm starting from here. 2 minus -1, 2 minus a -1. 9 minus 3 is just 6. And 2 minus -1 is 2 plus 1. So that's just 3, and so it simplifies to 2. Let's try reversing it. We should get the same number, and it's a good way for you to check your answer. So you could say you're starting here instead. And so you have 3 minus 9 over -1 minus 2. So you have, in this case, the numerator will be -6, the denominator will be -3, the negatives cancel. So you end up with 6 over 3, which simplifies to 2. So you have to end up with the same number. It doesn't matter which order you do them, but the numerator, if you start with y2, then you have to start with x2. That's the most important thing. So we have the coordinate, we have the gradient as 2. So we have this. But we're missing the c, and I intentionally picked 4 and 9 because 2 and 9 because it's exactly the same. We're going to end up with 5 again. I just picked one that would fit the equation. So you can substitute -1 and 3 just as we did, or you can substitute 2 and 9 as well. Now, if we repeat the process just as we did and we found y equals to 2x plus 5, you need to check your answer. It would be good to check your answer, and it's good to substitute a number in here. So 2 and 9, let's test. So we're going to test. If I substitute 2, will I get 9? Well, let's see. 2 times 2 is 4 plus 5. That is 9, and yes, we get a 9. So it fits this. So we've discussed the form, we've discussed the two ways, the properties I've discussed in terms of increasing, decreasing, the y-intercept. The last thing I'm going to discuss is how to move from the gradient intercept form to the general form. So if I have, let's say, just as we had, 2x plus 5. The general form is basically just telling you, I want the x and y's to be together. So, and they're going to specify in the question what way they want it. Do they want it as this, or do they want it as this? Now, if we're going to do, I'm going to label them as A, and no, I'm going to label them as F1, so form 1, and F2, so form 2. First form and second form. So for the first form, it just wants the x and y's on the same side. So usually we like to keep the x's positive, and so it's better to just deal with the y. So if I subtract y from both sides, I end up canceling y. On the left-hand side, I'm going to get a 0 is equal to 2x minus y plus 5. It's okay to plug it in between. But I want it in this form, so I want any coefficients, constants to be on the other side of the equal sign. So I'll have to subtract 5 from both sides. So this is going to cancel out, and I end up with negative 5 equals to 2x minus y. So this is u being in the general form. If I want f2, then this would be the form. So you have 0 equals to 2x minus y plus 5, or we like to keep things on from left to right. So 2x minus y plus 5 equals to 0. So that's one example. Now, the reason they're going to ask you for this form is usually when you have fractions. So if I have y equals to 4 over 3x plus 11 over 3. Usually this is when they're going to ask you for the general form, because we don't like to keep things as fractions. And typically you'll get the same denominator here. If you don't have the same denominator, you have to make them the same. So what you're going to do is combine these two numbers. So you have two numbers or two terms that have the same denominator. It means you can bring them together. Now, I am not adding the 4x and 11 because they're different terms, but I can bring them under the same fraction. I'm also multiplying 4 by x because that's what it is here. We just don't write the multiplication sign, or this is x over 1. So you have 4x plus 11 over 3, and you either multiply by 3 on both sides, or you could use the method of cross multiplication, so that's the same thing. The goal of here is to get rid of this 3. And this will help you, so get rid of the denominator. And when I say get rid of, it doesn't mean to erase it. Obviously, here I'll have to do the calculations. So get rid of the denominator to get to general form. So I'm going to end up with 3y equals to 4x plus 11. And so I'm going to, again, my 4x is positive, so I'll just move the y. So I have 4x minus 3y plus 11. And if this is the general form they want, then that's it. You can stop here. If they want x and y's on one side and constants on another side, then it's going to be negative 11 equals to 4x minus 3y. You'll also notice that if your gradient is 4 over 3, so if this is your gradient, 4 over 3, then the numerator will go to x, and the denominator will go to y, but it's going to have a different sign. So if this was negative, then it would have been positive here. You can test it out and see. One thing you need to note is that you can't, some of you might have thought, well, if I have this, then I can just simply go 4 over 3x minus y plus 11 over 3. Now, this is not in general form, because your A, B, and D, so these are the coefficients, have to be integers. Now, there could be positive, negative integers, doesn't matter, but they have to be integers, and these are not. These are rational numbers, so they're fractions, which is why we were doing this method of canceling it out. So hopefully this video is clear. It's a complete compressed version of linear functions that are nice and simple, and usually you get real-life examples on them.